In the previous lesson, we talked about the concept of gradient and its logic. If you have not seen it, you can go back to the lesson. I'll leave a link in the description section of this new lesson so that you can review it before you come back to this new lesson. But in this one, I want us now to understand gradient of a line in the coordinate system. So what gradient means, it just shows how stiff a line is. Tells us how much y changes for each unit increase in x. So in simple terms, gradient, which is given by f, is just the change in x, with the change in y, divided by the change in x. But I want to show you what this change in y and change in x means. So let's say we have a graph like this, and we want to plot a straight line in this graph. So I can just pick random coordinates of the line. For example, in my case, I can pick 2 to represent x1. So x1 is 2. Then 3 to represent y1. So 3 represents y1. Then I can also pick 8 to represent x2. And I can pick 7 to represent y2. So if I enter all those values in these boxes and then I plot this line, you see it plots the line, the straight line, but you notice that in the graph, x was initially 2. Here on this graph, x was 2, but it changed from 2 all the way to 8. So the change in x is, which is given by x2 minus x1, is 8 minus 2. Then y, which was initially 3 here, it changed to 7 here. So the change in y, which is given by y1 minus y2, is given by 7 minus 3. So basically, the change in x means the x-axis change, and the change in y means the y-axis change. Or change in x means the horizontal change, and y means the vertical change. Once we take the vertical change divided by the horizontal change, we get the gradient of that line. For example, in our case, the gradient of this line. So if I was to calculate the gradient of this line, I would say m is equals to change in y, which is given by y2 minus y1, and we already have it, which was 7 minus 3, divided by change in x, which is given by x2 minus x1, which is 8 minus 2, and it gives us 7 minus 3 is 4, divided by 8 minus 2 is 6, which I can divide 2 by 2 by 2, comes by 2 by 2, 3. So the gradient of this line becomes 2 over 3. If I can represent the change here, you see the x-axis change is 6 and the y-axis change is 4. And that's why we took the vertical change, which is 4, divided by the horizontal change, which is 6, and we got the gradient to be 2 over 3. But to get this change, I had to subtract the values of y. The final value of y, I subtract the initial value of y, divided by the final value of x, I subtract the initial value of x. And then we get the gradient of that line. can we try another example? Let me guess other values here. Like, for example, I can say I start at 0 and insert something like 7, and then the x-axis changes 7, and then I can say this one is y ends up to equally, I can also say 7. Let's see how this one comes. You see, that's a straight line. That's an horizontal line, which if we were to calculate the gradient of this line, if I was to show the triangle, we only have the change in x. We only have the change in x. Let me do it here. The change in y is 0, but the change in x is 7. So the gradient of this line is 0, because if you divide 0 by a number, you still get 0. So in short, 0 gradient represents a situation where we had a change in x, but we did not have any change in y, like in our case. You can try with other different values in this graph and see the changes you'll get. But for now, can we try some examples here? In the first example, we are told to find the gradient of a line passing through 2 points, where point A has values 2, 3, and point B has values 8 and 7. And we already know gradient, which is given by M, is equals to change in y. Actually, this means change in y or change in x, which is given by y2 minus y1 divided by x2 minus x1. So in our case, we have A, which is given by 2, 3, and then B, which is given by 7. So our x1 is 2, our y1 is 3, our x2 is 8, and y2 is 7. So our change in y and change in x will be y2 minus y1 divided by x2 minus x1, which becomes 4 power 6, which is 2 over 3. Can we try another example here? It is given by, can we do another example where we have 2 points C and D, as C is given by 1, 2, and D is given by 5, 10. So in the coordinate system, 1 is our x1 and 2 is our y1, 5 is our x2, and 10 is our y2. So gradient, which is given by y2 minus y1 divided by x2 minus x1, so it becomes y2, which is 10, minus y1, which is 2, divided by x2, which is 5, minus x1, which is 1, becomes 10 minus 2, which is 8, then 5 minus 1, which is 4. So the gradient of this line is 2. Let us verify from our graph if the vertical change of this line is 8 and the horizontal change is 4. So we had our coordinates. The first one was x1 was 1, and y1 was 2, and x2 was 5, and y2 was 10. So if I plot the line and then show the triangle, you'll see change in x, which is the horizontal change, is 4, as we got here, and the vertical change is 8, which is change in y. So we are correct. Can you try question 3? Well, can we also try together? We have 2 points, which is E given by 0, 4 and F given by 4, 0. So in this case, x1 is 0, y1 is 4, x2 is 4, and then y2 is 0. So if we want the gradient of this, which is given by m, this y2 minus y1 divided by x2 minus x1, which is the same as 0, which is y2 minus y1, which is also 4, divided by x2, which is 4, minus 0, becomes negative 4 divided by 4, which is the same as negative 1. So the gradient of this line is negative 1. Can we verify it in our graph? Let's try to end down the values. X1 was 0, x2 was y1 was 4, then x2 was 4, and y2 was 0. Let's try to plot this line. You see it's a following line, and if I show the triangle, that will show us with the gradient being negative 1. So negative gradient shows a falling line, but positive gradient shows a rising line.